Here we're going to deal with some bearings. So just remember what a bearing, if you ever see the word bearing in a mathematical sense, it means clockwise from north. So an angle measured clockwise from north, and pretty much all of the time, north is going to be an arrow and it goes straight up, as can be seen on this particular diagram. So the diagram shows a point P that is 10 kilometers due south of a point D. A straight road PQ is such that the compass bearing of Q from P is 45 degrees. A and B are 2 points on this road that are both 8 kilometers from D. Find the bearing of B from D to 3 significant figures. So this is quite nice because all of this information is given. We've been given a diagram. You didn't need. It's perfectly reasonable that you could have produced that whole diagram just from the information. You've got the 10 kilometers due south. That's clearly just a line straight down of length 10. Bearing of Q from P, it's even put that in. That means from north being straight up, go clockwise, 45 degrees. That's there. 2 points on the road, both 8 kilometers from D. They've drawn the 2 nice lines there as well. And you need to find the bearing of B from D. They've even told you what angle you're looking for. The bearing of B from D, which means you start at D, you draw a north arrow, and then you go clockwise, as in then you have to turn through that angle in order to be facing the place where you're going, as in B in this case. So we need to find that angle. So looking at that angle, it's going to take a bit of work to get to it. Basically, we're probably going to have to find this angle, which is going to involve some work on the small triangle. And then I think we're going to have to work out this angle as well, which we can't do right now. We don't have enough information for that right now. So I'm going to find the red angle first, and then I'm going to build up from there. So let's see, how can we find this red angle? We certainly can't use the cosine rule because you can only use that to find an angle when you have all 3 sides in a triangle. So in this triangle from triangle APD, we only have 2 sides. We have the 8 and the 10. So there's no right angle. It's got to be the sine rule. So the sine rule is about pairs of opposite sides and angles. So you have an 8, which is opposite the 45. So there's one pair. But the angle that I actually want to find, I don't have that opposite side. But I do have one other side, but the 10, it's opposite this angle here. So it's getting a bit messy on there. But basically, let's just get another color. I should be able to find this purple angle. That's opposite the 10, using the pair that I have, which is the 8 kilometer length and 45 degrees, which is this pair here, and the other pair, the 10 and the unknown. And then I've got the triangle. I'm going to have to just take away from 180. It's often missed, that case of the sine rule, where you find one angle and just literally just take away from 180. Or you take away from 180 and then use the sine rule. That is missed quite a lot. But yeah, I think just to remember, if you can't use the cosine rule and you can't use SOHCAHTOA, it's got to be the sine rule. So there's got to be a way that it can work. Right, so I'm just going to call this angle here A. So that would be sine A over the side opposite, 10, equals sine of the 45 over its side opposite. Over opposite 45 is an 8. Okay, so sine A equals 10 sine 45 over 8. You could, 45 is one of our nice angles, so you could work that out, but I'm going to have to use the calculator anyway. The fact that it's also 3 significant figures, you might as well just use the calculator. Otherwise, you're going to be dealing with messy fractions anyway. So 10 sine 45 over 8. 10 times sine 45 over 8. So So that gives us 0.883883. 883. So that must mean A is the inverse sine of that. A equals arcsine 0.883883 dot 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 equals, so shift sine A and S equals 62.114433. If we go up to our calculator, this is a bit of a worry because that angle to me looks obtuse. So I reckon we're going to have to convert that to an obtuse angle, because this angle that we want, it looks really small. So I'm going to say that A actually is obtuse. So that means, just think about your unit circle. 62 degrees is about here. So we're interested in this angle, which is 180 take 62. So A equals 180 take away 62.114433. So that equals 180 minus A and S equals, that gives us 117.8855. 56, I guess. So the red angle that we're going to use, the angle at D, is going to be 180. Take away the angle we've just found, 117.88 dot dot dot. Also take away the 45. So the angle's in a triangle. Well, we already knew that 180 take away the 117 bit is going to be the 62.11. So let's say 62.11443316. Take away 45. It's going to leave us a really small angle, which looks sensible from the diagram. So 17.114433. Okay, so go to our diagram. This angle D in here is around 17.1. Okay, so really we've got one more angle to find, which is this one here, and then we'll be able to use very basic angle rules in order to find theta. Okay, so once we've got that blue angle. Now, if you notice this, and always do look for things like this, you've got an 8 and an 8. Those sides are the same length. If they're the same length, it means you've got an isosceles triangle, which means that these two angles are equal. We can work out these angles because they're just 180. You've got a straight line here. It's 180 minus that purple angle. Well, 180 take away purple angle is 117-ish. And we know already that 180 minus that is 62.1, because 180 minus 62.1 is that. So it's the 62.1. So this blue angle D is going to be 180 take away 2 times 62.1. Okay, so to their calculators, 180 minus 2 times 62 point, do try and use some accuracy, 11443316. That gives us 55.7711. That'll do. Okay, now finally, to get to theta, we've got this north arrow, so that's a straight line there. So all of these angles here are angles on a straight line. They add up to 180 degrees. So theta plus the blue angle plus the red angle equals 180. So we can just subtract from 180. So theta is going to be 180. Take away the red angle, 17.1. Take away the blue angle, 55.77. And there. Okay, go to our calculator, 180. We can take away A and S for the 55.11. And for the 17, we also have it there, so 17.11443316. And that gives us an answer for theta of 107.1144. So we're going to say that's 107 degrees to 3 significant figures. Okay, and theta, as we were told, or as they drew it for us, that is the bearing of B from D.